Number 1. A 1,000 feet length of number 8 AWG copper wire has a resistance of 0.628 ohm at 20 degrees Celsius. Determine the resistance of this same mass of copper if it were drawn down to one half of the cross section. Okay, so in this type of problem, it means that the final condition, the cross-sectional area of the final condition has been drawn down to one half. Okay, so let's determine, so then we need to determine the resistance. Okay, so first, let's recall the formula. Formula of resistance is equal to resistivity length all over the cross-sectional area. So do we have the value of our resistance? Yes, it's given in the problem. How about for the resistivity? None. Okay, so how about for length? Yes. How about cross-sectional area? None. So our first step, uh, you can see that the resistance is 0.6 at 20 degrees Celsius. Okay, if you recall our lecture problem discussion in part 1 for the resistance, we have the value of resistivity at 20 degrees Celsius standard. Okay, so that is equal to 10.37 ohm circular mil per foot. Okay, so if we use this resistivity value, we can determine the value of our cross-sectional area, which is that is our um, going to determine first. Okay, then we apply this one half effect uh, because of the process droning process. Okay, so let's determine and apply. Okay. So what is our resistance? That is 0.628 ohms is equal to our resistivity, which is 10.37 ohm circular mil per foot. Then 1,000 feet length all over, the resistance has been drawn down to one half, so that is one half is also equal to 0.5, so this is 0.5, then our cross-sectional area. Now we can determine the cross-sectional area. That is the only unknown, but before that we cancel the common units, so to check if our answer is really aligned with our unknown. So ohms, both sides cancel, feet cancel. So the remaining unit is in circular mil, which is the unit of your cross-sectional area. Okay, doing the math, the value of your cross-sectional area, you just use the power of calculator, shift solve. The value of your cross-sectional area is equal to 33,025,4777 circular mil. So that is the value of your cross-sectional area when drawn down to one half. Now, we are asked to determine the final resistance when the cross-sectional area is drawn down to one half. So let's substitute the determined value of our cross-sectional area back to our original, back to the formula. Okay, so finally our resistance is equal to, we use the same resistivity, which is 10.37 ohm circular mil per foot, the same distance, that is 1,000 feet, all over the value of our drawn down cross-sectional area, circular mil. Okay, so let's cancel the common unit. So feet cancel, circular mil cancel, so the remaining unit is ohms, which is the unit of your resistance. Okay, so doing the math, the final answer of your resistance is 0.314 ohms. So this is the value of your resistance of the new resistance when your cross-sectional area is drawn down to one half of its cross-sectional area. So if we try to check, let's check our answer, 0.628. That is almost, it means that if the resistance, if we try to check the 50%, the 50% of 0.628, that is equal to 0.314. Okay, that is almost 50% changes. The resistance dropped down 50% when the cross-sectional area dropped down to 50% also. So they are directly proportional. When the resistance when the cross-sectional area changes, it directly affects your resistance. Okay.